Good morning, everyone. It's good to see the room full. It's actually been great to see Diane's work. I come from CoreOS. I was running the product team at CoreOS, and for the last year, I've been helping here with the next generation OpenShift platform, which we call OpenShift 4, which you're going to hear quite a bit about. But it's really good to see the room full here, and this is the second, actually it's the third Commons event that I've been at. The first one was Buenos Aires, where we had over 600 people. It was amazing to see that room full. And KubeCon, which had, I think, over 400 people. So these events continue to impress me. And I wanted to, before getting started with my presentation, I wanted to thank Diane. She's been doing amazing work running these events and bringing this community together. And by the way, she won the community award at the last KubeCon too. All right, so let's get started. Now, before, Diane talked about the how and the what of the community we're trying to build here. But I wanted to step back and talk about the why, at least one important reasons behind the why. And to me, that starts a while back in 2003, where there was an article that came out called IT Doesn't Matter. Now, I want to see show of hands, who remembers this article? Okay, a couple of show of hands. Let me do another show of hands. Who was actually in the industry in 2003? Okay, that's pretty good. About half of the room. If I just put back my mind to that time, I was a young consultant, just starting my career as a computer scientist, and this article caused a lot of stir. People were going out there saying, well, you know what we have, the industry we're in is not going to go anywhere because IT doesn't matter, and IT is going to commoditize over time. And the premise was that IT is going to commoditize. It's going to become like a service like electricity, where you just plug into it, and there won't be much innovation needed by companies out there from an IT perspective in order to gain a competitive advantage. Now, if I fast forward to now, and I look just at the last week, and just day-to-day things I've been doing, right? I use Uber on a regular basis, although today I took 2 hours ride from Marin to here, which I should have probably used Uber. But that innovation was not there. That has been fundamentally disruptive to the basic commute industry. If I look at Concur, anyone from Concur here, by the way? Oh, I think some of the folks are coming, and they run on Tectonic, which is some of the technologies that we're putting into OpenShift 4. Now, I use Concur all the time, and I remember back in 2003, using the expense systems that were around was night and day to using Concur. It's just so much easier, and they completely disrupted that industry. If I look at the airline industry, and if I look at what I use today when I want to watch a movie inside the airplane compared to back then, again, technology has completely disrupted that. And if I look at what I can do in the airplane using the Wi-Fi, something as simple as going on Amazon and starting to order some resources and actually run compute on demand. Again, nothing like that was around in 2006, 2003, not even close to it. So who here thinks then that, based on what I just said, this article, Nicholas Carr, was right? Anyone? Now, obviously, I'm presenting a biased view on this, but no? Well, I actually think he was somewhat right. So let me explain why. Because I think that last example I used does give you some commoditization of IT. Right? If I want to go get compute resources, again, it's now like a utility. And I'm actually, in fact, charged on it like a utility. Sometimes very often I end up getting bills from Amazon where I think I've closed everything up, but I haven't, and I still get that 50 cents for that elastic caching, whatever it is, and that feels like a utility. So what's going on here? We've innovated, we're continuing to innovate, but yet there is the commoditization happening. And I would argue that it all depends at what layer you're looking at this. If you're looking at it from a compute infrastructure perspective, I would argue that is well on its way to commoditization. In fact, the utility companies for that are becoming fewer and fewer. We know them all. But if you look at the layers above that, if you look just one layer above at the type of services that are available for application developers, application owners to build their application, innovation is still thriving. I mean, one just has to look at the number of projects that are being donated to the CNCF just to see a little bit of that, right? The type of projects that are being there, like Vitesse and like Harbor and other projects that are being donated there, the innovation is still happening. So then you go one level above that, and to argue that enterprises do not need to build applications in order to disrupt their industry and continue plowing ahead on top of this stack, obviously would not make any sense. So innovation is happening at the top layers, but at the infrastructure level, it is on its way to commoditization, I would argue. And in fact, going back to Nicholas Carr's argument, the same thing would apply to electricity. Not many folks are innovating at the electrical infrastructure level, but yet the electrical services level, you would say innovation is still probably happening. Innovation in battery power, innovation in just going to Starbucks and putting your cell phone on a table and getting it charged automatically wirelessly. These are innovations at the electrical services level. And of course, at the appliance level, well, we'll continue to innovate in terms of electrical appliances, obviously. There is one important difference between the IT world and the electrical world that worries me, and that goes to the root of why I think this community of people really matter. And what we all are doing in the open source community and across all the projects we're involved in matter. And that is that with electricity, you actually have the option of moving your electrical appliance from one electrical provider to the other without much effort. And let's take a look at how this happened. It almost was by chance, but essentially when electricity was introduced back in the days of Edison and Tesla, it was mainly first introduced for lighting. And light bulbs were created. The light bulb interface was created. But then folks realized, well, I need to create other appliances, and I need to plug that in. So you can see there's a toaster there, the big picture. There is a hair straightener, and there's a food warmer. And all of them, the food warmer actually goes up into the ceiling, have the plug that goes into the electrical plug. And that's because they leverage that interface as a standard interface for plugging into the electrical service, the infrastructure service. Now imagine if this hadn't developed that way. That would mean that if I wanted to move to San Diego and I wanted to move my toaster, if I wanted to move to another state, it would be like I would have to change country today, even worse. I would have to rewrite my toaster in order to move it from one place to the other. And that would have been a tragedy. So to me, the question is, how do we make sure that this doesn't happen in the IT world? Because the way we're going right now, if the electrical providers of the IT world, which I would equate to the big cloud providers, have their way, we would use very proprietary services that tie you deeply into their infrastructure and make it very difficult for us to move our applications from one electrical provider to the other. And it's very difficult to actually resist that because the flexibility that those services provide, the benefits that those services provide are huge. And so how does one fight that? How does one work with that environment and figure out a way where you get the flexibility, but also at the same time get the portability. That's one big why that I think this type of community is really working in solving. So I wanted to talk about how. From our perspective, from Red Hat's perspective, it's all about having that true hybrid cloud experience. If you go to the Amazon console, if you go to the Google console, you get this amazing cloud experience where you can see all of your compute fabrics, you can see all the various different types of services, and you can deploy applications that leverage those services, and the whole thing kind of runs, right? It updates by itself. You don't have to worry about how it's built. It just works. Well, imagine if you could get the same benefits, but in a truly hybrid model, where you could deploy those fabrics on any infrastructure provider, and you could leverage the services that are beyond the services that those cloud providers provide, and tap into the diversity of services that the software vendor ecosystem is building out there. And actually consume those services in the same way. So self-service, auto-provisioned, metered, automatically updated, and so on. So that's what we internally call the unified hybrid cloud. And we are working with our community to actually rally behind and build. Now, the unified hybrid cloud, to me, the three pillars behind it are as follows. First, Kubernetes. Second, it's all about automated operations. And third is all about actual hybrid services on top of the whole thing. Let me tackle these three in turn. Kubernetes. I think at this point it's easy to say that for the infrastructure of the future, yes, there's a lot of infrastructure from mainframes to vSphere to standard apps that just run on their own EC2 instances. That exists plenty out there. I understand that. But the infrastructure of the future is becoming more and more clear that is becoming containerized infrastructure, and for the orchestration of that workload, that is becoming Kubernetes. It's good from my perspective that Red Hat took a chance on Kubernetes back in 2015 along with CoreOS, and it's good to see all the other vendors jumping in as well now. Now, what that gives Red Hat is an advantage that I think is important in this why, which is that we're one of the biggest contributors, as you saw with some Diane's slide, to Kubernetes. But if you look at another axis, if you look about infrastructure neutrality and who is well positioned to actually drive these initiatives that allow for portability, Red Hat also stands out. Now, automated operations. This was actually at the core of CoreOS, which was all about how do you make everything more automated because we're outnumbered out there. I ran across this quote, which I think summarizes the philosophy of CoreOS, and some of the early CoreOS folks here might disagree with me, but I think this is a good summary of the philosophy of the CoreOS philosophy. I'll let you read it for yourself. It's by a management consultant from the 1960s. I think the same quote probably applies to the data center of the future. And this is what CoreOS was out there to achieve, is to make sure that operation becomes boring no matter what infrastructure, whether on your own premises or any cloud provider you're running, doesn't matter where you're running, it becomes boring. And if you look at the CoreOS Tectonic stack, Tectonic was CoreOS's Kubernetes product. If you look at that stack, it started from the operating system with Container Linux, which was our operating system that operated on an automatic basis. We had over 200 instances of Container Linux running out there, listening into different channels, and whenever we would push that button for updates to be sent every 2 weeks, 100,000 plus instances of operating system would get updated. And we brought that up to the Kubernetes layer with over 6,000 clusters being updated every month. And so that stack is being placed at the core of the next generation OpenShift stack. And all of the OpenShift capabilities that the OpenShift customers and community are used to is being maintained on top of that stack. That's the green stuff. That's where we're going from bringing in automated operations to OpenShift. Now, installation, of course, matters too. We want to make the installation of your infrastructure as simple and automated as possible. We're not going to demo it to you here, but internally, using the OpenShift 4 stack, Clayton Coleman, who's one of our lead evangelists out there, has created a tool on Slack where I can create an OpenShift instance using a Slack command called launch in less than 20 minutes. Right? I just do a launch. I get back the coordinates for my Kubernetes cluster. And that's how simple OpenShift 4 has made installation. And Ali later on is going to dig into the details of how that works and what it's all about. The updates, I'm just going to talk about this a little bit, but essentially the way updates work is that clusters can be registered to this notion of channels. And they can receive updates on these channels. In the Tectonic world, we had a pre-production channel and a production channel. We first pushed updates to a pre-production channel. You would receive a note as an administrator that an update is available. You can then decide to apply the update. A cluster of over 100 nodes, usually it takes about 15 to 20 minutes for that update to work, including updates that go across minor versions of Kubernetes. And of course, you still need deep visibility into how the cluster is doing. And that's why we are bringing in, starting with OpenShift 3.11, deep observability capabilities, starting with Prometheus being baked in and also having its own automated operations through the Prometheus operator with predefined dashboards that are embedded into OpenShift, as well as Grafana dashboards that you can customize. But this goes beyond in that you're going to see with OpenShift 4 an Istio layer that gives you an OpenShift service mesh that's integrated with Jaeger for tracing, as well as its own first-class UI. Moving on to, okay, we've got Kubernetes. That gives you some level of sort of neutralization layer to the infrastructures that are out there. Then you've got automated operations on Kubernetes and the operating system, doesn't matter where it runs. But we haven't talked about those compute services, right? How do you make sure now that the applications that you build don't end up using a proprietary service that ties it right into a single cloud provider? And that's where, for us, the operator framework came in. We introduced the operator framework a little bit over a year ago. And this is, in a nutshell, it's about making it possible for software vendors and software builders, really, to bring in automated operations on top of Kubernetes easily, making it easy to tap into Kubernetes events and take the right actions so that your database auto-scales, making it easy to receive an update payload and apply it to the different instances of your service that are running there. So the thing is, if software vendors leverage these tools, the idea is, then the consumers of those software on Kubernetes environments can benefit from the same benefits as any service that a cloud provider provides, yet have also the benefits of portability and more. And a good example of that to me is the Crunchy operator. So the Crunchy operator, if you compare it to the alternative, exemplifies what I just said. So before, if you just wanted to run a database, well, RDS gives you a database on demand, self-service auto-provision, automatically updated, automatically replicated. If I compare that to me trying to go find on Docker Hub one of the dozen Postgres images that are out there and trying to figure out which one is just good enough for me, and then doing a Docker run of that thing, and then hoping that it works, and then having it automatically replicated and set up with its storage volumes, is going to take me quite a bit more time and maintenance of day two operations over time compared to RDS. But if I run the Crunchy operator, well, I can do a kubectl create of that It's automatically hooked up for updates. It's automatically doing the replication. And by the way, it can run on any Kubernetes. And by the way, it's open source and has advanced observability capabilities that RDS doesn't. So now, suddenly, the flexibility argument changes, because as a consumer, I can have my cake and eat it too, because I can choose a service that's portable and gives me those cloud-like interfaces no matter where it is. And so we launched OperatorHub.io along with Amazon, Google, Microsoft, just about 2 weeks ago, I believe. And the goal there was, we saw from the time we introduced the operator framework to last couple of months, over 100 operators being created out there. What was hard, though, was to find the operators that met certain criteria in terms of quality of documentation, in terms of how much activity they have by the community that's behind them. And so the goal of OperatorHub.io is to create that single place where you can easily find all of these automated operation-driven services that are out there that are also portable and that can run anywhere. So if you go there, you'll see how to contribute to it. The goal of the community, or hope for the community, is that this continues to thrive. I know we've got a couple of other ones that are coming up that have been submitted just as of last week. And we hope that many of the 100+ operators that we know are out there are going to make it here. But we're putting that first bar of curation to make sure that certain qualities are met before they get in. And we're doing that in collaboration, that's interesting to me, with the cloud providers. Because the cloud providers are also seeing that this reality is inescapable. And over time, we need to address that problem. I always get this question of, what about serverless? You've talked about all this stuff, but what about serverless? And to me, that question is interesting, because serverless is, depends what you mean. But the way I like to think about it is from two aspects. One is a question of scaling out the workload to zero when there's no workload coming in, and scaling back up based on an event-driven model. And the other aspect, which is somewhat orthogonal, is a question of function as a service, building functions versus applications in any other way. Knative, to us, was a project that was very promising, because it allows us to have all the constructs to bring those benefits to the containerized infrastructure world in a way that allows us to meet the mandate I was just talking about, which is full portability and therefore hybrid. And so with the work we're doing, and we're going to get into a lot more detail on that with the presentation Redbeard is going to be giving on Knative and OpenShift, what we're doing there is enabling serverless on any workload, on any event. So you're going to have a starting point set of events that we're going to bring in through CamelK. So if a Kafka topic has certain event on it, then please start up this application. By the way, notice I said application, not function, because you can start up a function on a serverless basis or your Spring Boot app on a serverless basis. It doesn't matter. But what's also interesting here is that your operators can plug into this and actually act as new event sources and start their own serverless events. So you're no longer limited to the 7 event sources that Lambda gives you or the 5 that Microsoft gives you. And by the way, which all of them, I think, are tied to proprietary services. So that's the premise by which we're driving our serverless strategy, and I'm really excited about that. In general, stepping back, what we're working on when we say platform services is providing a set of services that create a platform that allow the ecosystem out there to build portable services on top of OpenShift so that we can achieve that goal of portability and cloud-like experience no matter where you are. So with that in mind, I'd like to conclude. That's what we call the unified hybrid cloud. You're going to see the beginnings of that with OpenShift 4. In fact, you're going to be able to try that, and I think Ali is going to talk about how. You are going to see cloud.redhat.com come to life and start exposing some of what I've just talked about in terms of that cloud-like experience across everything, but truly portable and truly hybrid. And we're excited to work with you, the community that's behind us, and that's really been a driving force in making all of this happen going forward to make all of this a reality. So thank you for being here, and thanks for all of your help, and looking forward to continue to work together. Thank you.